Example 16, the coplanar force system in the figure consists of three forces and one couple. Determine the equivalent force couple system with the force acting at point O. So following Varignon's theorem, we will resolve our forces. Let us say we'll have this one as F sub 1. So we have F sub 1 y goes up, F sub 1x is to the right, and let us have this as F sub 2. So F sub 2y is going down, and F sub 2x is going to the left. Now, if you can observe, some of our unit is in, at the length, the unit of our length is in mm, and whenever we encounter this kind of units, for SI, we must always present or report our answer in the base form, which is Newton meter. So therefore, we'll be converting mm to m later. But for English system, you just stick with what is given. So let us say if given is in inches, then you write pound inch. If you given is in feet, you write pound foot. Okay, or pound feet. So we start by finding the resultant force. F sub r. So we have the x component of our resultant force is equal to the sum of all the forces in the x direction, assuming to the right positive. So we have to the right, so that's 90. And then f sub 1x plus f sub 1x, that's 50 times cosine 40. 50 cosine 40 degrees. And lastly, we have minus f sub 2x, which is, if you can observe, our ratio is 3, 4. So it must be that our hypotenuse is 5. So we have 3/5. That is 100 times 3/5. So our f sub r sub x is equal to 50 cosine 40 is 38.3222216 plus 90 minus 100 times 3 divided by 5. That's 68. 68.302222216. Let me 100 times 3 divide 5. 50 cosine 40 minus answer. And then 90 plus answer is indeed 68. Okay. And then summation, y component of our resultant force is equal to the sum of all the forces in the y direction, assuming upward positive. So this is equal to, if you can observe, there are only two forces, and that is 50 sine 40. This is 50 sine 40 degrees minus our y, which is 4/5. 100 times 4/5. So this is 100 times 4/5. So our f sub r y uh, is equal to 100 times 4 divided 5 is 100 times 4 divided 5. That's 80. So 50 sine 40 minus answer. That's negative 47.8606195 and of course in mm, or is my cursor Newton? Oh yeah, I forgot to input Newton here. So we write our y component following its true direction. So F sub R y is equal to positive 47.8606195 Newton, and it's going down. Okay, knowing these two values, magnitude of F sub R. So we have F sub R is equal to the square root of F sub R x plus F sub R y squared. This is equal to square root of 68.30222216 squared plus 47.8606195 Again, I am using the positive because we already know that f sub ry is going down. So that's 68.30222216 squared plus 47.8606195 squared. Take the square root, and that is 83.4016339 Newton. That is our F sub R. And the direction of F sub R is equal to theta is equal to tangent inverse of F sub ry over F sub rx, which is equal to inverse tangent 47.8606195 divided by 68.302222216. So theta is equal to 47.8606152 divided by 68.302222216. Inverse tangent around 35.0196334.8 degrees going down to the right. Okay. Now for our resultant moment about point O. Is it point O, right? Yeah. Let me uh erase this one. Okay. Resultant moment. This is, this is moment about point O, assuming counterclockwise positive is equal to all the moment plus the moment coupled. So what are all the moments? So take note that we are taking our moment about point O. So therefore, both f sub 2y and f sub 2x, which is the x and y component of our 100 Newton force, will not be considered because both of their line of actions passes through point O. So only consider 90 x x and y components of F sub 1, which is of our 15 Newton, and our 14 Newton meter couple. So if you can observe, our 90 Newton follows a clockwise moment, 40 Newton meter clockwise as well. F sub 1y follows a counterclockwise moment, and F sub 1x follows a clockwise moment. So we follow first what is positive, and that is F sub 1y, and its perpendicular distance is 800 mm. So that is F sub 1y times 800, and then minus now, because like I said, f sub 1x is follows a clockwise moment, and its perpendicular distance is 500 mm. So f sub 1x minus f sub 1x times 500, and then minus our 90, which has a this perpendicular distance of 600 mm, 600, and of course our couple moment, which is 14 Newton, but it follows a clockwise moment, so therefore minus 40. Okay, so we have f sub 1y is 50 sine 40. So this is 50 sine 40 degrees times 800 minus our 50 cosine 40 degrees times 500 minus our 90 times 600. Now, if you can observe, 40 is in Newton meter, but our 800, 500, and 600 is in mm. So therefore, we multiply all of these by 1 over 1000 to convert it to meter. So then minus 40. This is equal to 50 sine 40 times 800. So this is 25,711.50439. Let me calculate it again. 50 sine 40 times 800, 25711.50439 minus 50 cosine 40 is around 38 times 500, and that is 151.1111. No, no, just three ones. 11108, 11108. And then minus 90 times 600, and that is 54,000. And all of these close open bracket parentheses 1 over 1000 minus 40 This is equal to 25,711.50439 minus 19,151.11108 minus 54,000. So this is, let me divide it with 1,000 immediately. So that's negative 47.439,60669 minus 40. So this is negative 87.439,60669. And this our unit is now in Newton meter, and we will report our answer in following the true sense of our moment, and that is positive 87.439,60669 Newton meter, and that is clockwise. Okay, there you have it.